There you go. I should.
Можно сделать либо переходить на новый, либо просто делать YouTube и оттуда выбирать. Да, просто как бы сразу, что вроде как бы
Hey guys, can you get started now?
Соответственно, он построит вроде как очень южно. Не знаю, как в этом порядке для положения, но приоритетно. Ну да, да, не видно, как это.
Okay, I'm going to get going. Hopefully you guys can still hear me. So, for those of you who haven't met me before, I'm Vish. I work at Google and I guess the name is too religious. Just to go back to the case. So I'm Vish. I work at Google on Kubernetes. I've been working on Kubernetes for a year and a half now. I used to work on CLI, and then became from Docker. I used to be a Docker maintainer for a while as well. So I'm being pretty familiar with the space. It's been an exciting journey being with Kubernetes and the community, and the fact that it's open source, and the fact that I get to meet all these amazing people, and it's like an organism that's growing rather than like a single person's idea or just a company's idea. It's a huge deal, and it's been exciting. So we also have Eric today. Eric leads a lot of things in Kubernetes in addition to art, and he's going to be, like, we both are going to be co-presenting, and we're going to be talking about all that stuff today. So I'm going to get going. So before I get into the details, which is like if I do demos, I just want to give an idea of like what happens in Kubernetes. So here's some GitHub stats. So we have like 54 contributors. I haven't tried to be so new contributors there, but we have like at least 54 contributors who have the 1.3 meetings. And we have like 2,700 commits. It's amazing. Like, given that we had about 2.5 to 3 months to come up with release, like going through that many commits was a huge deal. And this is just a Kubernetes repository. It doesn't include other repositories like Helm or Heapster, CLadvisor, or like a whole bunch of other things. So this is just a Kubernetes repository. And in the core, there's like more than 1 million lines of change. I'm not saying all of this is virtual code. There's a lot of mentoring that goes on. But there's still a lot of code that goes through our system, both build and test system. And this thing is working, and that's amazing. So as part of this whole 1.3 effort and continuing after 1.3, the community has spent a lot of time trying to improve the scale and automation. So if you posted a patch to GitHub, you will be seeing our bots doing a lot of things. They try to identify the right moments. They try to like identify fake tests. They try to match them with existing issues. we try to assign flaky test issues to the test owners. And I think they're like getting into machine learning stuff there as well. So basically like building a lot of infrastructure on top of GitHub to scale the project. And testing has also been a critical thing. So we're trying to figure out how to scale testing, how to distribute testing, and there's been a lot of work going on there. So for those of us who have been with Kubernetes for a while, we've been using these changes, and it's been a pleasant change, and it's been an awesome change. And now, like getting into features, so cross-cluster federation was a big deal. So cross-federated services work as part of monolithic. There's a lot of work going on for other API objects to be available in the federation. For those of you who don't know what federation means, it's basically like rather than having a single cluster, you have a bunch of clusters, and so you get like high availability, fault tolerance, and all that. So you can load balance across Amazon and your on-prem like GC, or you can just have multiple clusters on Amazon itself. So you just have a lot of options, and you can build like regions and zones, and you can have like geolocality. I'm going to get into that in a little bit. And then we have support for stateful applications, which means like something that a lot of people have been asking for a while. So you finally have like alpha support for stateful applications, so you can like try running ECD, Sandra, MySQL, and a bunch of other stateful apps now. We spent a whole lot of time trying to get local development environment to work. For those of you who tried to use Kubernetes maybe like 6 months back, you would know how hard it is to set up a cluster if you're outside of GCP or AWS. It's a problem. Like we've known that it's a problem, and we're working hard towards eliminating it because main reason is like Kubernetes is hard. Like, it's a bunch of components, and each one does awesome stuff, but like putting them together is not too good. But then we realized like there are two classes of users. There's the ones who set up production clusters, and there are end users. Like end users are people who write applications that run on Kubernetes. So we want people to be able to write Kubernetes apps, test it locally on your laptop. So just like do a Docker build, do a compilation, do a Docker build, run them as Kubernetes pods in your laptop, test it, and then you can deploy the same configuration to production. So almost all of the portable features that Kubernetes provides would be available to you locally. You're not going to get the same performance, obviously, you're not going to get scalability and stuff, but it's just made to test your app and your config. And that's about it. So we worked a lot on that, and then this Rocket support, that's amazing. Like for people who have been running Docker in production, we know how many problems that it causes. I don't want to get into the details here just because of time, but like it's not trivial to maintain Docker in production. So we finally getting Rocket support. A shout out to Kubernetes folks here, and they're working very hard. We're almost there. It's not yet there completely. And then we have an updated UI, which I'm going to show in just a bit. So I'm going to start off with Minikube, which is our local development environment. So it's basically a single command installation. It works across Linux and Mac as of now. Windows support is happening as we speak. It includes all the dependencies. You basically have like a single binary that you run. I'm going to try to show you. Let's see how much time we have. I'm going to try to go to the repo. I'm going to copy the installation instruction, and I'm downloading it. I'm actually going to try to set it up. Let's see. Okay, so Minikube is installed. So I'm just going to say Minikube start. It's going to take like a minute maybe to set up the cluster, but while it does that, I'm just going to go back to the slides and just talk a little bit more about it. So it's got a built-in dashboard, and so basically what it does is like it gives you a lightweight virtual machine that's running on your laptop, and it runs all the Kubernetes components inside, and it sets up your config, and you don't have to worry about it. You get a working Kubernetes cluster at that point, and then you can just start using kubectl to do all your awesome things. You don't, as I said, like, you don't get some of the more non-portable features like load balancers, specific load balancers, or like specific storage devices, but the rest of the concepts do just work. anything, any Kubernetes concept that's portable should just work. So clusters now happen. Let's just do a kubectl get nodes. So we have any cube running. So I'm going to see if I can open up the dashboard.
14 frames.
Okay, not sure where I tried to open. Oh, it's right here. Here we go. So the dashboard is outside, and then if you get into the cube system interface, you see the dashboard running, and then you have an add-on manager running. But basically, it's functioning cluster by all these. It's GA as in like it's not alpha or beta. It's just available for everybody to use. So please go use it and give us your feedback. We are fixing issues as people find issues. So try it out. If you find an issue, just go to the Minikube repo on Kubernetes and find an issue. I want to give a huge shout out to a few people who made this possible. Dan, Lucius, and Jimmy. They've done a lot of work and continue to shape Minikube. So the next thing that I want to talk about is init containers. So init containers is an alpha feature. So we have often we have situations where you have to take your binary and you have to sort of customize it to make it work in different environments. If you're running in Mesos and you want to run it in Kubernetes, then you have to change some concepts because things work differently in Kubernetes. Or you would have thought like, okay, now I have a Docker container, but I don't want to run the binary instead of Docker container. Can I download the binary before I start my container? Can I just have like say Ubuntu as my base image and I just download all the dependencies as part of the pod deployment? You can do that now. Or have you thought like I want to have an easy way to manage configuration for my applications? I don't want to change my app. My app just takes in configuration however it wants to, but I still want a flexible way to get config and then configure my app. That used to be a little difficult than before containers were there, but now that's straightforward. So you can like initialize a database, you can do a bunch of things with that. So the primary idea with init containers is that you define some special containers which are run serially, and it's required that all those containers run to success. And once all of them run to success in that specified order, that's when the application containers are started. So application containers are usually run in parallel, whereas init containers are run serially. So what does this buy you? It buys you, so you reduce coupling between your images. So if you're building an application, you have a team that's building an application, you just focus on the app. You don't have to worry about how to make my app work well in this given environment. And that's someone else's problem. So you have you can build images separately and you don't have to combine these things. You don't have to build multiple images just to make sure your app runs on different platforms or different orchestration systems. So I'm going to try to do a demo of this. Let's see how it goes. So I have scripted demos here. Let's see. So I'm going to be using Minikube for this demo, Mr. Ross. So I'm going to create a test namespace just for this. And here's the config. So you see init containers being defined here. It's an alpha feature, so you see the annotations because there's some facets of this feature that are still being resolved. So this is how it's currently being defined. It's an alpha feature, so you might have to turn it on by yourself because not all the hosts or all the people who host Kubernetes will give you this feature by default. So here I've defined a busybox container that tries to get the entry page in Kubernetes.io, and then it puts in a specific folder, and it basically puts it in as workload volume. And the same workload volume is being mounted into an Nginx container, and the Nginx container uses the same volume and the same data here to serve web pages. So I'm going to go ahead and create. I'm going to go ahead and create this pod. So the pod has been created. So let's see that the pod is running. So it's saying that it's pulling the image. So this logs are already there, and then the container was started. So unless the container succeeded, it's not going to start the Nginx container. So any container has to succeed. So I'm going to open up a service just to access the Nginx container, which is an app container, not an init container. Because init containers are expected to run through function. So since I'm using Minikube, makes my life really easy. So they set up a node port on me and it's giving me a URL, and here we go. Like, we have the init container ran, it fetched the index.html with girls.io, and then now my Nginx container is serving the traffic, serving the web page. So I'm going to delete the demo namespace. Then let's keep going. So pet sets are specifically meant to help run cluster applications in Kubernetes. So if you wondered, like, how do I run Cassandra or ECD or FlexDB when they have clustering? Like, how do I set these up? Like, they all have ordering requirements. They have identity requirements, and then they have data locality requirements and data retention requirements. It's not trivial to set these things up. You often have to do it manually. You have to be sure that you don't screw up. But now Kubernetes provides a few abstractions that help you run different classes of cluster applications using these standard concepts. So the guarantees that Kubernetes provide are mainly around identity and sequencing. So you get, each app gets its specific identity that's retained through its lifetime, and you also get sequencing. So you might want to use pet sets if any of these features matter to you. Like if you want a stable host name across all restarts, then you might want it. And if you want alternate indexing, if you're running 10 copies, typically with pods we say like, so you have the pets versus tablet. I don't want to use the term, but you know what I mean. Like you just have things that you can just stamp, and you don't care about whether you have a specific instance of that, because they are stateless in some sense now. They can be replaced by something else. So that's the regular pods. Whereas when it comes to pet sets, you have pods that you really care about. It's not trivial to bring them up, and it's not trivial to replace them. So you want to be sure that they are running and they get real identity. And you also want stable storage. Like you don't want storage to go away. Like you don't want EPCD to go down, and storage to also be blown away. You want the data there. Like data really matters to you. And often these kind of apps also want to discover their peers. So they also want to do like bring up a core. In some class of apps here, like MySQL with Postgres. I guess that's pretty obvious. So I'm going to try to do a demo here. The demo is not focused on running any one of these popular apps, but it's more focused on like showing what Kubernetes can do for you, so you can build these apps. Before I do that, I also want to give a huge shout out to Kate and Prashant, who put a ton of energy into getting this work. I'm sure that there are a lot more contributors who have shaped this. I just mentioned the ones that I know personally. So if anyone out there hears this and feels something that I apologize. So I'm going to be doing the same demo. I have a k8 cluster set up for this purpose, so I can use like first some risks and like I can also like virtual volumes on the fly. So I'm going to be creating a test namespace, just like I did in the previous demo. So here's the pet set configuration. So pet sets have two entities. So you have a governance service to which all the pets are linked to. So in this case, it's a headless service, and what it means is like the headless service is primarily meant to help group and identify pods. It's not meant to serve or route traffic. So with a headless service, you can do a DNS query and you get like all the pods that back this headless service. So you can imagine how this will be useful. Like setting up an ECD and you want to know who your peers are, then you go look up, do a DNS query against the headless service, and you get a list of peers. And then here's the pet set configuration. So we're configuring a pet set named web, and then we're linking it to the service named Nginx, which is an endless service. And just starting an Nginx container essentially. And we're also like setting up storage for this. So this is auto version of the storage. So you're saying that storage class can be whatever. I don't have any performance requirements. And it's saying that your minimum storage requirement is like 1 gigabyte. So let's go ahead and do that. So we created Nginx and we created a pet set web. But before I proceed, I also want to make sure that they're running. So I'm going to spin up a Q proxy. Sure you guys cannot see this, and it doesn't matter. So I'm going to go over here and have the dashboard open. So you can see that 2 pods were started. First one 0, and second one 1 is yet to be started. And we also notice here that we named the pet set as web, and then we said like it has 2 instances. So you have your ordering here, so you have your indexing here, so you have 0 and you have 1, and they start in that order. And this is going to be stable. I'm going to show you like how it remains stable. Just going to wait for the one to be running, and it's running now. So let's go back. And so you can see the 2 pods running, which we already saw from the dashboard. And I'm going to list the persistent volumes that are here. So Kubernetes has automatically provisioned 2 volumes for me, and so I won't get into the details of explaining how persistent volumes work, but it's basically like you have a loose company, so your cluster administrator can provision a bunch of volumes with different capacities and like different volumes of service. And then as an application operator, you just request for one of those volumes, and like binding would be done by Kubernetes. So you just get the volume, you don't have to worry about the volume came from. So we have 2 volumes here, and I just extract into first container, and then I run hosting. So you have, like you can see that you have stable hosting. So you have web 0, which is the same pod name that we observed. I'm going to get into the second pod and just look at its hosting, which is the one in this case. So, and let's see how the DNS entries is set up. So I'm going to try to look up, so I created a new pod, and I'm extending into the new pod, and I'm trying to look up first pod, web 0, and then Nginx is the service name. So the way DNS entries are created is like, you have your pod name, so you have your pet set name, and then you have your identity, and then you have your service name. So that's the grouping that you get. So I try to look up the service and the service exists. And second, I'll show like how. So I can basically identify these 2 pods now, but I'll also show like how you can identify your peers. So I'm going to delete the test pod. And if the pods get deleted, they will be restarted automatically. Remember, the volumes are separate from the pods, so if the pods are they can still come back and the volumes are still down. So pods are still being set up. Let's go back to the UI and make sure that the pods are running. Yeah, they're running now. I extract back into first pod, web 0, and the host name is stable, so even if it restarts, you get the same host name. And then on the other pod, same thing, you get the same host name as we saw earlier. And let's look at how we can discover peers now. So again, I'm starting a test pod. It's not related to the main pods that are created. And I'm going to extract into the test pod. I guess it's still not running. So let's go back to the dashboard. Just make sure that the test pod is running. And it's running now. Like that was. So I'm going to run this command manually. go. So by looking for Nginx, Nginx in this case is the headless service, and then demos is the namespace. So I'm like basically asking for specific namespace. I get a list of peers in my service. So these two, so I can run the same command from within one of my bed pods. I can discover all my peers. So going back to the demo. So I'm going to delete the left pod, I'm going to delete the left side, but remember if you delete the left side, the pod is still around, so you need to go manually delete them. So I'm going to delete the pod. And one more important thing, your storage does not get auto deleted. That's on purpose. So you have to go and remove your service of your storage. Storage data is really important. So deleting the pods now, and also storage is still there, we're deleting storage names, and deleting the namespace time. Boom. I didn't expect that to work. Yes, awesome. So cross-cluster federated services. There was a meetup on this topic, I think maybe a month back or 2 months back. I think we went into like a lot of detail there, so I don't want to get into that much detail. Maybe I'll just talk about what features is available in Node 3. So what's available in Node 3 is like, you can create multiple clusters, and you can create a federated control plane on top of those clusters. And the federated control plane is functionally equivalent to a regular Kubernetes cluster, and like the API concepts you interact with are the same. So what this buys you is like, you can have different groupings of these clusters. So for example, in the US, you can have like western region, central region, and eastern region. And then if any one of those regions goes down, then you can just like load balance across to within the US is the first. Before you used to move traffic over to Europe, or same thing would happen in Europe. So you can have like groupings at different hierarchical levels, and like federation gives you that. So what happens is like, once you set up your federated federation control plane, then you can create a service to the federated API server. And the service is the same thing as like an on-the-Kubernetes service. Then what it does is like it goes and creates the same service across all the clusters that belong to the federation. And if there is any traffic flowing into the service from within a given cluster, and if there are pods that are backing the service, then your traffic will not exit the cluster, your traffic will be out. Whereas if there are no backing pods for the given service, then traffic will be given to the next hierarchical region. So if you have, like, say, US, your east region doesn't have any backing pods for the service, then traffic would go over to, say, western region, central region. And so that's the first thing. Second thing is, DNS entries are being set up automatically for you. So if you're running on AWS, like Route 53 is only being populated for you. So you also get like specific domain, so you can like have hierarchical groupings in there. So depending on what an end user tries to query, like if you query specifically for Europe and they go to Europe, if they just query generally, then their traffic gets distributed to any one of the global zones. And as part of all of this, there's also like L3 load balancers that are being automatically set up for you. And those L3 load balancer IPs are also distributed across all the clusters. So all this like just works for you. I'm not going to go over and do a demo for this, one because we've already done it, and two because it takes quite a bit of time. We don't have the time here. But I'll give you a link. I'm going to post these slides, and there's a link in there where k8s did a huge, awesome demo. So if you guys are interested, I would suggest go checking it out. By the way, it's beta in Node 3. Oh, before moving on, there have been a lot of people who are working on this, along with Quentin, Justin, and quite a few other people. So I just want to give a huge shout out to who is working on this. Please continue doing your work, this is awesome. So, since we talked about multi-cluster, I also wanted to touch upon a more, like, federation is one thing, but at the same time, even to run a federated service, you need like bootstrapping. Right? You need a cluster that's stable, that's relatively stable, so you can run your federated control plane. So that's where Node stepped in. these don't require multiple flushes, but rather like you have a single flusher that's spread across multiple different zones within the same region. So if a single zone goes down, so this is not the cloud providers, like essentially you don't usually have region-wide outage, you have like zone-wide outage. So if you have a single zone that goes down, then you get to like distribute your load to another zone. But that's not it. You get a lot of features through node pools. So you can set up heterogeneous nodes. So if you start your cluster with say like 4 CPUs and maybe like 30 pieces of RAM, and then you figure out that, oh, I'm going to run this Uber application that's going to eat all the RAM that I've got, so I need like a bigger node pool. And I want to run this specialized app just on that. How can you do that? Like you can create a node pool with like a custom machine size and just run specific set of workloads on that. And you also get to do A/B testing. You get to do a staged rollout. You can, once you create a new node pool, you get the newest version automatically, so you can like slowly start moving your workloads from old version to your version. Once you feel it's safe, then you can quickly switch over to the new version. So I have a very short demo on this. Let's see if we can do it. Am I already short time? Yeah, I guess maybe it's going to see this demo. Oh, off. Yeah, Eric.
Hi, Eric. So I'm going to do 2 little things about authorization and auth. So this first part's about GKE only. Shout out to CJ Cole, who implemented this in GKE and open source. Our goal with this release was to make it easy to invite somebody else to use your cluster, and to just start to introduce the idea of having different roles on a cluster. And Google, like AWS, also we both offer fairly expansive IAM systems, and we think that people that come to either of those clouds are going to want to centralize their authorization information in one place and have it work across all the different cloud services. So this is part of bringing Kubernetes into this. It's kind of a different sort of problem because it's open source software rather than like software that's written by your cloud providers. That's been an interesting problem internally for us. So the way this works, if you have in 1.3, is if you use Google Cloud, you have a gcloud client. That client has a token. You can give gcloud a command to take that token and put it somewhere kubectl can find it. And when you do kubectl get pods, it's going to send that token along to the API server. The API server is then going to send that token to a internal Google authenticator and say, who is this person? In this case, said, oh, it's Eric. So it's going to take that email name. API server is then going to be able to record that email name. You can audit log it and stuff like that. Then it's going to quickly after that go make an authorization decision. So it's going to send that email name and information about the operation that's happening. In this case, getting pods. It's going to send it to Google's internal permission system and say, is Eric allowed to get pods on Kubernetes cluster XYZ? And that's going to say yes. And so if you go to the next slide, I'll show what the prereqs are. One more slide. So you have to have 1.3 for your client and for your cluster. And so if we can switch to my screen share real quick, is that possible?
Yeah.
I'm already sharing.
Then Rose just needs to switch here.
Okay. So I went to my cloud.google.com console and I clicked on my. We're not speaking, huh? Can you just go over the
Or I can just share. Okay.
Okay, so I went to my cloud.google.com console and I invited Vish by his email to join my project, and I made it a reviewer rather than a developer. So now Vish is going to go back and attempt access to my cluster. But
Okay.
trust me before, like,
Yeah. Well done.
So one of the nice things about this now is that you can have a centralized place the and I also have like the same actual credentials that I already have with the cloud. And I never have to get those credentials. I shouldn't have to do that. And yet he's able to access my cluster.
So, am I correct that it's also connected to the, I mean, I can use my own company Active Directory that connected to the Google, and in that case I can define in my Active Directory new group, say Kubernetes developer, and in that case, that people can get the access. Oh, it's not just...
So in 1.3, we just use the project permissions. Actually don't know, I know that you can have your Active Directory connect to Google Cloud Platform. I don't know how that works with groups and permissions. So if you can do that like with GCP, then you can also do it with k8. In the future, we will have finer-grained roles. This is our first pass at roles.
Oh.
And that will continue to work the way it's described.
Okay, so the only writer right now.
We're just reader and writer right now. We understand people will want to like customize those, and it's a journey.
Okay. Okay.
Okay, I'm going to run through the demo.
Okay, so this for 1.3, you have to tell it not to get a client certificate, which is this irrevocable credential that the first 1.2 previous Kubernetes used. And you have to just basically tell it to use your Google Cloud token, which is this really short lifetime credential. And he was able to list what clusters I have, and he's going to download the credentials, and that's going to populate his .kube/config with something that says use my GCP credentials, and then it's periodically going to copy those over from where Google Cloud stores them. And he's able to see my odds, but he is not allowed to delete them. Sounds simple, but this was actually exciting for us. Like a year of planning to get this point. Okay, so second thing I want to talk about is open source. So through AWS, we love, and you understand their IAM system, and you want to help integrate with Kubernetes, please come talk to me afterwards. I have ideas, but not expertise. On GCP, you can see that it's going to be more integrated with GCP IAM. If you're on-prem and you don't have a centralized authorization system, well, if you, let's say you're using OpenStack and you love Keystone, we're working in the direction of saying, well, I don't want to use GCP, I want to use Keystone. So that'll be an option. If you want something new, we have something new. This is role-based access control. This was developed in OpenShift first, about a year ago, based on collaboration between OpenShift and people on Kubernetes. And now we've upstreamed it. Big shout out to David Eads and Jordan Liggett from Red Hat, who, oh my gosh, that is incorrect, I'm so sorry. David Eads and Jordan Liggett are at Red Hat. Eric Schnall is at CoreOS. I apologize, CoreOS people, for that. Okay, all right. Eric Schnall from CoreOS has been doing on source once again with my collaboration with a bunch of people in the community. Actually, yeah. So it allows you to create a lot of different roles, make custom roles. It allows you to assign those to all different users and groups. It is conceptually similar to what AWS and GCP offer, which should be familiar with you to those. And something that's important to us is as we add new kinds to Kubernetes, as long as they follow the same REST path sort of rubric, rigmarole, then they can also naturally extend into this authorization system. So, next slide. So, we have four kinds. I'll talk about cluster role first. So, role is just, people are probably familiar with that. It's a set of permissions, the ability to do things. Cluster role means that it applies to the whole cluster. And so, I've defined this role named pod reader, and it has a rule that says the It applies to resource pods, and it allows you to do these verbs, get, watch, and list, which are the verbs that involve reading things. And so the other concept, besides a role, next slide, is a role binding, and that attaches users. It can also attach groups or service accounts to that role. So in Kubernetes, we don't store user records or group records. We assume any reasonable company already has that, and we're looking to make it so that you can, your authentication system is supposed to bring that information with you when you authenticate someone. But authorization, people don't usually have a generic REST authorization system, so we are providing that. If you go to the next slide. So in Kubernetes, we have 4 types of objects. We have cluster role and cluster role binding. Those are not namespace. They apply to the whole cluster. And then we have namespaced objects that live only in namespace. So in this example, you have a role, the other 2 types of objects are role and role binding, which you can also think of as namespace role and namespace role binding, except we didn't make you type those extras, whatever, 9 letters. So these arrows show possible linkages between role bindings or cluster role bindings and roles or cluster roles. So arrow 1, Eric's, there's a role binding that binds Eric to the cluster role of pod reader. That means that Eric can read pods in the whole cluster, regardless of what namespace they're in. So in namespace default, there's a role binding that says that it binds fish to the pod reader role. When the binding comes from a namespace to a cluster role, it acts like a template. It causes like the cluster role to only have effect in the namespace scope to the namespace, whereas when the binding is from the non-namespace level, it's everywhere. And likewise, so the idea of having a cluster role, it allows, like, if you have a multi-tenant system, to delegate authority to tenants to create custom roles that only make sense to them, and not have other tenants be able to see those roles or care about those roles or manage those roles. And there's a cover check, so that, like, if you delegate authority to someone in a namespace to create their own roles, they still can't create authorities that they wouldn't already have themselves. The one thing you can't do is you can't have a cluster role binding point to an namespace role. That would just be silly. So that's it.
So it's not the most actually. So I also want to touch about scalability. We did a lot of work in monolithic scalability. So we officially support 2,000 nodes and 6,000 pods. And also see our ones that can SLA here. So pods are expected to start within a second second. It doesn't mean that you can't extend beyond 2,000, so you can grow, but like just have less. And good probably grow beyond 6,000 pods. So these are the defaults that we testing for SLAs. There's a great blog post about this which talks about different API operations and latencies. Link to this slide. And I also want to talk about node stability because it's often not considered. Like if you're running this Docker, often you run on this space or like you start a bunch of containers and they start moving each other, and like if they get stuck, you run into like different issues and you cluster the essentially break after a while. You need like relays nodes, bring them, it's very expensive. So we need to put a lot of effort when it comes to node stability in Kubernetes. We're working towards the point that all your resources are appropriately distributed. The user applications, user applications are both when it comes to like CPU, memory, disk I/O, disk usage, like all sorts of resources Kubernetes can handle. And we also added support for user space configuration. So if you configure so you have very flexible policy. So for example, let's say that I set a policy that if my coding there I'm going to be associated clients, just make sure that like it drops all of that. It doesn't go below. So if it goes to less than 500, then queue that on the nodes is going to go find the pod, kill it, to make sure that you're not going to have space above your time next to it. So it's going to keep doing that, and it also takes care of on bonding as well as. And it also takes into account that. So it takes into account how much time is I'm deliberately not getting the details here, but it's a very flexible policy that like if you're a cloud provider, if you want to guarantee some sort of SLA to your end users, you can still expose that SLA to the system. It's data technology, which means that it's open, so you have to run it on manually, but in order to you have to enable it. So it's just that. We're also working towards doing this technically with this research. And finally, I also want to say that nodes are scalable beyond 100 bars as now. Just again, it's not that you are going beyond that number, it's just that that's the number that we estimate. Make sure that it goes to that. I talked about this. I keep mentioning it because it's easy purpose that it redefines how an engineer runtime can be. Like Docker doesn't even want to be, but it's still like tending towards a system that is awesome. But still, when you think about it, Docker doesn't do things that are not good for production. Like they have logs, they take this resources. Like it's just too hard to think of how you critically run Docker in production. Whereas like Rocket doing out the whole thing, they ensure that like whole runtime is modular, your control plane doesn't interfere with your management plane doesn't interfere with your monitoring plane. And it's like very based on consistency, which is also very well established right now. And it provides a lot of amazing features like you have configurable isolation levels. So if you want to run your pod in the production machine, or just run as a system, like just using shivers. So it's not fully functional, it's mostly functional. So your scroll is also working hard on getting the last few issues resolved so that it's like production ready. As I said, do check it out. If you're running with the production, you're running issues, give it out by doing stuff first. Talk about a lot of features, there are some features. If you notice, like I said, the beginning of the organic this is growing organically. Like it's getting a lot of contributors. Like I met this person who was 6 years old, high school student. He's so enthusiastic about contributing to this. It's amazing. Like it's not that he gets paid or anything. It's like this loves the whole project. He wants to do more and more. So it's spreading really wide. It's like it's one of the top projects. We have a lot of new contributors. Like 1200 projects, I'm slightly the number. Here are like some of companies that are contributing and are like, using. This is not exhaustive. Just to give an idea on like who is growing. And I also want to stress on the other fact that it's open. It's completely open. We started with like, a few concepts and like, everything we're developing from that point onwards over the last year or the last 2 years actually has been on open. Like it's on GitHub, and everything is shared on this. It's nothing hidden anywhere. Like it's basically engineering. It's like engineering how this work. The world expresses its opinion, you take the best opinion, and then that wins and that goes. If you have open ideas, if you have experience in this field, just jump in. It can be a little daunting as to come together and figure out what I can contribute. So we have like special interest groups. So there are different special interest groups, like for example, there's special interest group focusing on road, on media, on authorization, on scalability. So you have like these different classes, and what is your interest or specialization? You can find the group, get in touch with the ones who are in that group, and figure out how to solve it. And I guess I don't have to talk about how to get in touch with us. So just get on to Kubernetes.io and like all of you guys should do that. Finally, thanks a lot for patiently listening to what I've been saying all along. I hope you guys give Kubernetes a try if you haven't already done so, and give us feedback. Thank you very much. Okay. Next up, we have speakers from Days. We have Michelle from Days, who's going to talk about health. So it's very straightforward to start. Like it's getting straightforward to start with Kubernetes, but like managing apps with Kubernetes at scale is an interesting problem. So I'm very excited to know more about what
Okay. Thanks.
It says searching. Is your laptop detected, right? Here we go. Is yours? Okay, sure. Thank you.
Hi, my name is Michelle Norley, and I'm going to tell you a little bit about the Kubernetes Helm project. Is anyone familiar with Helm in this room? Okay, cool. And who used Helm Classic, not Kubernetes? Oh, cool. Oh, hi. Okay, awesome. So I'm new to this meetup, so I'm going to tell you a little bit about myself before I get into the project. My name is Michelle. I'm a core contributor on the Kubernetes Helm project. I also help run the Kubernetes special interest group for running applications. I just moved to Boulder, Colorado a few months ago, so I appreciate any opportunity to come back to the Bay Area and hang out, so thanks for having me. I'm primarily a Go developer, but I have Ruby roots. And I like coffee, anything that contains goat cheese, and pretending to be outdoorsy. I hate typing in gopath/src/github.com. It's the bane of my existence right now, so I have a lot of bash aliases. And I work at a company called Deis. So Deis has, the word has Latin roots. It means raised surface or platform. We love Kubernetes, we bet on Kubernetes, and we do everything we can to build tools to help make managing and deploying apps on Kubernetes easier for everyone else. And so Deis Workflow is one of our projects. It's an open source platform as a service built on top of Kubernetes. It consists of multiple components, and together they comprise of this developer self-service experience and give developers this Heroku-inspired workflow to deploy apps into Kubernetes. And what's cool is that you don't have to use all the components. You can use them individually. And Helm is what we use to install Deis onto Kubernetes. And this is kind of how Helm came to be. And so in October of last year, in fall of last year, we were working on workflow and we came across a few problems. First of all, we really needed a way to repeatedly install Deis Workflow onto Kubernetes. And each component had its own manifest or set of manifests, and so we wanted an easier way to manage all of our Kubernetes manifests. And we also found that each developer would tweak the resource definition just a little bit for their own environment. And so we wanted a way to be able to do that easily as well. And so we came up with this concept of Helm. And so what we realized, what we really wanted in Kubernetes was something like apps, something like Yum, something like NPM or pip or Homebrew. And so we were like, okay, cool, some sort of package management system. And so we created Helm, heavily modeled it after Homebrew, and that's how we described it to everyone else. And so Helm became a Kubernetes package manager. And a package in our Helm universe is a chart. And a chart is super simple. It's just a group of manifest files and some metadata. And where we store charts, we call that a chart repository. And so, like I said, this became our installer. We even added support for Go templates so that we could tweak our manifest files really easily. And so, yeah, so we started on this in October, and then a month later, we debuted it at KubeCon, and we didn't anticipate the amount of uptake that it actually got in the community, and so we got really excited about it. We got lots of community support and input and feedback and feature requests, and what this grew into was a way to share information about running common applications and services inside of Kubernetes. And that grew into a really simple and clean way to onboard newcomers on Kubernetes. And so if I, as an app developer, have figured out how to install a particular app, let's use WordPress for an example. If I figure that out, then nobody else needs to figure that out again. I can just make a chart and then post that chart, and then newcomers can see that, and all of the rest of the charts, and really get an idea for what the patterns are to build apps on a Kubernetes, or in Kubernetes. And Helm's great, but it had some limitations. So there was no in-cluster component to Helm. So you could install charts and you could uninstall charts. But when your charts was actually in, or when your resources were created in Kubernetes, you couldn't actually manage them in the cluster. And also we had solved this problem of collaborating like with sharing charts and manifest and resources, but we couldn't really collaborate as a team on one particular cluster. Every Helm client was its own island, and so there was no communication there. So in January of 2016, we started talking to Google. They came over and they were like, hey, we're doing this project called Deployment Manager, and we have some of the same goals. So let's collaborate efforts. And we're like, yeah, because we understand stuff from Helm Classic, some mistakes we made, some lessons learned, and they had some stuff from, some battle scars from Deployment Manager, and we're like, this is great. So we started working on the project Kubernetes Helm. And so Helm, the original one, is now called Helm Classic, and that's how I refer to it, and we all refer to it. We renamed the project to Helm Classic, and Helm is now under the Kubernetes org in GitHub. So this is a brand new project, and some of the goals of this project were we just wanted to make it easier to install and configure apps. We want to minimize chart development overhead, and we learned that from Helm Classic, and we want to make collaboration amongst teams easy, and we want to require little or less effort from operations, and basically give all of us more time to grab some coffee, do our nails, go play Pokemon Go, because those are important things in life. And so Kubernetes Helm has two components. Helm is still the client, and Tiller is the server. And so Tiller is a cute little pod, and he lives in Kubernetes all lonely until you start installing charts, and then he manages the instance of charts that you installed. So we talked about how Kubernetes came about and came to be thus far. So now we're in present day, and this is what Kubernetes Helm is right now. In Kubernetes Helm, there are three main concepts. The first is the chart. It's the expert-built recipe for installing an application. And it's pretty similar to what the chart format was for Helm Classic, but it's grown just a little bit, and we'll talk about that. So if I, as a person who figured out how to do WordPress on Kubernetes, I'm going to build a chart to do that, and I'm the expert on that. And that's great, but not every app is the same. Each app is unique in its own right. And so we want to make sure that the chart can specify things that a user, an end user of the chart can configure. And so that's where values come in. And so values are the user supplied configuration that is merged into a chart at install time. So these are the knobs that you can twist and turn when you actually pull down a chart, things you can configure. And together, they come together during the release step to create a release. So when you do an install, we create a release. Build plus config equals release. We base that off 12 factor. So charts are all grown up. They still have the chart.yaml file, which contains the metadata. The manifest directory, which contained the resource definitions, is now called templates. The values file is just user supplied configuration. So those are the knobs you can turn in a chart that the chart developer has specified, and you can override those as well. And then there's this idea of dependencies. So originally, or in the previous iterations of Helm, we were like, oh, we're just going to specify that this chart depends on another chart, and then at install time, we're going to go fetch that chart and install it into the cluster, and it'll be super easy. And that's actually not a great way to go about this, because what happens is that that chart that you specified changed while you were sleeping, and then the next day when you came in, the chart, the release that you were expecting to get is no longer the case. So now we just vendor all of the dependencies under a charts directory in the actual chart. And this gives you deterministic, repeatable builds, which is always good. So I'm gonna see if this works. Okay. That's really small text, right? Can everyone see that? All right, so when you first get Helm, you want to run the init command. The init command specifies, it just sets up local configurations, a dot file with some config files inside of that, or a dot directory and some config files inside of that we need for the Helm client. And then it also installs Tiller into your running Kubernetes cluster. Now, if you don't want to install Tiller right then and there, you don't have a cluster running, then you can just pass in this client-only flag. And I've already done this on a GKE cluster that's running. I can't type and talk, so I'm going to put this down for a second. And here you see the Tiller pod running. Oh, now we can hear. Okay, that's the Tiller pod. Okay. So what we're going to want to do with Helm is install charts. A chart looks like this. We have some example charts in the Helm repository. So the chart.yaml file, the metadata, the values file, and the templates. Let's look at the template. This is something you can configure, the pod name in this particular chart. And the way you do that is you go back to this values file, and there's a default in there called my Alpine. And so that's basically the that particular chart. So we'll go back here. We'll say Helm install, and then we'll give it a path to a directory that contains a chart. Samples. This is way harder than I thought it's going to be doing. Multitasking. Okay, so when you install a chart, it'll give you a random release name. So this is Wizen Turkey. If you want to have less fun in life, then you can pass in the -n command and some name, and it'll give you like a release name of your choice. But I also talked about the overrides. So let's see. Say I don't like the name that was given, then I can provide my own YAML, and I'm going to name this pod Michelle's School Pod, and then I'm going to do this install again, the -f flag, and give it the path to the file, and it'll give me another release. I don't know what an Ikinda is. Do you know, Slack? No. Okay. I'm going to ask the person who wrote this generator. So let's go ahead and see what happens. So now we have Michelle's Cool Pod, we have my Alpine, and so you've installed your chart. Other things you can do with Helm is you can list your releases, and you can, mean hamster was what I did earlier, and I just love the name so much, so I left it in there. So yeah, you can filter. Let's see what else you can do. Okay, so this is where collaboration comes in. So so Slack is at Deis2, and say we're on the same team, and I decide to push up this chart and some configuration up to our cluster, and then I'm like, hey, there's this last-minute airfare thing, discount to go to the Bahamas. I'm going, peace out, and then everything falls apart. So Slack will say, hey, I'm going to go ahead and see what Homegirl did. So I'm passing in the release name, and that'll give me the manifest file that was generated with all of the values. It'll give me the user supplied value, so you can see what I actually configured, and some other metadata information to help you debug. And then there's a bunch of subcommands with get that you can check out as well. You can delete a release. I guess we'll delete Helm or Mean Hamster. You're right. I can't let go of that one. All right. And now you see that's terminating. And then also you can do some other things. Status is still in there, so. And you can see what the status is as well. Okay, so when you're ready to create your own chart, you can use the create command to actually scaffold a chart. So you'll pass in a name to the create command and it'll just give you the directory structure that you need. You can, after you're done developing your chart and you're ready to share it with the world, then you'll package it and this will give you a tarball of your chart and the name of it will be your chart dash version. And so that's super important because in Helm Classic we learned you shouldn't just pass around expanded directories of charts because you'll never know like which version that actually is without looking in the YAML file and it can cause a lot of confusion. So charts live in chart repositories and so we use Google Cloud Storage, people use S3, and so basically you can add repositories to your Helm client, and so when you add a chart repository to your Helm client, it'll basically give you an index, it'll store an index of all of the charts that are in that repo, and then you can search for a particular chart. So the Helm client talks to Tiller. Tiller actually does the whole merging of the charts and the values, it does the deployment, and then it's the interface for the state tracking of a release, and it also talks to Kubi API to actually do creating stuff. And there's some repo commands in there. You can add a repo and give it a short name. A chart repository is anything that can talk to HTTP, HTTPS. So we just do a get to grab the index file on the chart. You can fetch a chart. So fetching a chart means, hey, there's a remote chart somewhere out in the world. Slack created a chart yesterday and he's like super eager for me to check it out. So I can fetch it, I can untar it, and then I can start experimenting with it. So basically, Helm is a way to manage and create Kubernetes native applications. We manage charts. Charts are groups of Kubernetes resources. Helm is the client, Tiller is the server, Tiller manages releases, and that's where you can find the project, and it's a part of the CNCF. And so what we've done recently and what we're working on right now for the Alpha 3 release, which should be coming up pretty soon, is we just added this concept of hooks. So before an install or before an upgrade or after and delete, before and after those actions, you can maybe run hooks, something like a job, and basically give it an annotation, and we'll run that based on which type of hook you've supplied. So I'm actually working on the ability to upgrade releases with the new of a chart. And we're now storing release information in config maps instead of in memory. And we're also getting the Kubernetes charts repository into shape. We just had a meeting about that this morning. So I'm really excited. We've been working with folks from Google and Bitnami, and they've been pretty passionate about creating charts. So if that's something that you're interested in, please let me know. And that's the Helm team at Deis. It's not the whole team. Like, we have people from Bitnami, we have people from Google. But basically, I put this picture up there so that y'all can see we're nice, we don't bite. And if you have issues, please come and talk to us. If you want to try out Helm, we'd love to talk to you about it and help in any way we can. And we have public stand-ups on Thursday mornings. And this is where everybody kind of does their own stand-up on the team. And if any community members are working on something, they can do a stand-up. And if you have a problem with a chart, you can talk about that. But yeah, we don't bite. And that's just some other information. That's it. That's all I got. Anybody have questions?
So you got a repository where you keep your chart information.
Yeah.
How secure is that information? And is it high availability or is it a single server?
So we just use, we don't create our own chart repository. We just use Google Cloud Storage. And right now things are public, but we're working on creating private chart repositories, since that's something that everybody will probably want for their own team. So it's on the roadmap. Oh, and we have, oh, go ahead.
So I'm wondering how do you plan to deal with versioning of the charts? Planning to just use GitHub style,
No, you explicitly tell, you explicitly say what version your chart is in the metadata in the chart.yaml file.
Using style for maybe? I mean.
Oh, yeah, Semver. We
Okay.
use master version.
So you mentioned that there is no in-cluster components. Are you going to add them?
Yeah, so Tiller is the in-cluster component. There was not an in-cluster component in the old Helm, the first version of Helm.
Oh, okay. Oh, let me give that. So the question is, let's say in cluster, there is some resource, shared resource, and I would like to run my chart that use this shared resource.
Yeah.
How can I say that in the configuration?
It depends on what it is, but mainly services and label selectors is how you would figure out
Okay.
how to connect that. We have some books, some of these children's guides. So if you have children, just come see me after, and I'm gonna read this to my dog. So feel free to take your dog next week. Yeah. So that's it. Anybody else have questions? Oh yeah.
Yeah. Thank you.